In this video, we're going to take a look at a couple of the big gotchas around mappings. Again, in general, we can consider them to be like JavaScript objects, but they are different in some very specific ways. Let's first take a look at a normal JavaScript object, and I want you to see some of the things that we can do with a JavaScript object very easily. So I've got a little code snippet over here. Inside this little editor that I'm using, I can put some code in on the left-hand side, and then if that code produces any output, it'll automatically print on the right-hand side. So for example, if I type in the string, "hi there," you'll see that it automatically appears on the right. And if I paste that string several times, I get this identical output here on the right-hand side. So we're going to use this editor just to give you a quick review on some very common operations that we can use with JavaScript objects. Inside of here, you'll see that I've already got an object, and it lists out a little bit of a Spanish to English dictionary of sorts. The keys of this object are English colors, like red, green, and orange. And then on the right-hand side are the equivalent words in the Spanish language. So red in Spanish is rojo, green is verde, orange is naranja. I'm hoping I do my pronunciations there somewhat reasonably. If you're a Spanish speaker, I hope I didn't just butcher these words. Anyways, the point here is that with a JavaScript object, we can make use of a couple different methods to manipulate this object. In particular, I can use the method object.keys and then pass in Spanish colors like so, and I get back an array of all the different keys that my object has. Likewise, I can write out object.values and pass in Spanish colors, and I get out all the values. Another way that I very commonly might manipulate a JavaScript object is to say something like Spanish colors and then use bracket notation to access a particular key inside there. So I might say something like red, and that returns the value at key red, like so. One other thing that you will recall is that if I try to access a key that does not exist, this object will return the value undefined. So for example, if I put in that right there, I get back undefined, which in this editor prints as nothing. But if I put down equals 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 undefined, it says true. So clearly, yes, this does return undefined right here. So in total, we just walked through 4 very simple operations. Firstly, clearly we can easily retrieve all the keys that a JavaScript object has. We can easily retrieve all the different values that the object has. We can retrieve a single key, like so, by using the bracket notation. And if we try to access a key that is not defined, we get back a value of undefined. So with those 4 rules in mind, let's now go take a look at mappings with Solidity and get a better understanding of how they work. All right, so we're going to look at a couple diagrams here. Here's the first one. So I'm going to lay out a couple of big gotchas around mappings I want you to understand. And these are going to be in stark comparison to how JavaScript objects work. So the first big gotcha that we need to be aware of around mappings is that keys are not stored with mappings. Keys are not stored. And that might seem like a very strange thing to say. If we go back over here to JavaScript land, you and I very well know that we had just said a moment ago object.keys with Spanish colors, and that retrieves all these keys right here. So the same is not true with mappings. With mappings, we are working with a classic data structure called a hash table. With a hash table, we have something called a lookup process. So over here on the right-hand side, you can see the underlying data structure that represents our mapping, in this case with values of rojo, verde, and naranja. In order to look up some different value from this mapping right here, we have to provide a key ahead of time. We provide this key, the key gets passed to a hashing function, and the hashing function outputs some predetermined index. So maybe in this case, index 3. When we get this index 3 right here, Solidity then knows to go to index 3 inside the mapping and retrieve the value from that element right there. So in a Solidity mapping, keys are not stored. That means we cannot get a list of keys. We can't access them. We don't know what keys a mapping has. So if we start to define an object or a mapping inside of Solidity that looks like this right here, you and I cannot know after the fact whether or not red, green, and orange are defined keys unless we try to go and access those values. We can't get a list of these. We can't get a list at all. And this might sound like maybe a strange thing, maybe a weird thing. As soon as we start to write some code inside of our contract, I'll show you why this is a very relevant thing. And hopefully at that point, it'll also make a little bit more sense. Now, the next thing I want you to be aware of with mappings is that values are not iterable. In other words, we cannot loop through a mapping and print out all the different values that it has. This is very closely related to the fact that we just spoke a moment ago about how keys are not stored and we cannot access a list of keys. So in other words, if we have a mapping, we cannot write, say, a for loop that iterates through all the values. We cannot run any type of function or do any type of call that somehow says, okay, go into this mapping and retrieve all the values that exist. So like you just saw a moment ago, back inside the JavaScript world where we said object.values and got a list of all the values like so, we do not have this functionality inside of Solidity. We cannot get a list of all the different values that a mapping has. All we can ever do is do a lookup of values, like we saw just a moment ago by writing out something like Spanish colors, red, like that. So in other words, these mappings are only good for single value lookups. They're not good for storing information that we want to iterate over sometime in the future. Now, the next thing that's going to be a little bit surprising with mappings is that we say that with Solidity mappings, this is kind of like a quote that we use, we say that all values exist. So again, just a moment ago inside the JavaScript code editor, we saw that if we wrote out something like this, we got back undefined. So specifically a value that tells us, hey, that value has not been defined inside of this object before. The same is not true of mappings. So in other words, if I take that same Spanish colors object, convert it to a mapping, and then try to look up the key, say, Amarillo on it. Amarillo, which means yellow, by the way, or I guess so really this should be yellow because the keys were English. Anyways, if we put in yellow to the hashing function, we'll get back some index again. The index will be looked up inside the mapping. And rather than telling us that there's no value at that particular index, we will actually be returned some default value for that element right there. If these were all strings, then the default value would be empty string. So if we were to convert this to the JavaScript world, that means to say that if this was Solidity code right here, and we looked at Spanish colors and then tried to look up a key that does not exist, we do not get back undefined. Instead, we would get back an empty string. This default value that we get back from mappings depends on the value type of the values inside of our mapping. If these were not strings inside of our mapping, if they were instead, say, integers, then we would get back a 0 value for an integer, which in this case would be literally the number 0. So what this means is that in practice, it kind of makes it really challenging for us to decide whether or not a value exists inside of a mapping. Like, think about it. If you're storing numbers inside of a mapping as values, and you want to say, oh, do I have some value for the key red or the string yellow or something like that? Well, if you look up that yellow string inside the mapping and you get back the number 0, that kind of makes it challenging for you to decide whether or not, yes, that value already exists inside the mapping and it was set to 0, or no, that never existed inside of it and we just got back 0 because that's the default value. So in other words, the point here is that when we start to look up values or keys inside of a mapping, it's kind of tough to decide ahead of time whether or not that value actually exists or not. Now I think there's one last thing. Here we go. So last thing, understanding all this mapping stuff now, here's the final diagram of how our campaign contract is going to be laid out. So this is really the final design. So because mappings have the benefit of this constant time lookup, and we want to make sure that our contract can be used with many, many, many different contributors, we're going to do a little bit of a refactor. We're going to say that the approvers property is not going to be an array of addresses anymore. Instead, we're going to say that it is a mapping. It's going to be a mapping where the keys are addresses and the values are booleans. We'll know whether or not someone has donated to our campaign by looking up their address inside this mapping, and if that lookup returns true, then we'll say, okay, this person must belong. And maybe that might not make a lot of sense just yet, but as soon as we write the code for that, it'll make a lot more sense. And then a very similar thing, inside of our request struct, we're going to add on an approvals mapping So this is a mapping that tracks who has voted on a particular request. And then to track whether or not it's a yes vote or a no vote or anything like that, we're going to have a separate counter that counts the number of people who said yes. Now this part right here, this approval count, might be a little bit surprising. You might be thinking, well, why don't we just store whether or not someone does a yes or no vote in this approvals mapping right here? Well, remember, when we're working with a mapping, we cannot iterate through the mapping. So it's kind of pointless to store whether or not someone voted yes or no inside this mapping right here, because we can't iterate through it and try to total up all those values. Instead, we have to keep this separate counter around to track whether or not a person voted yes or no. All right, so that's a lot on mappings that we've now discussed without even looking at some of the basic syntax around it. So we still have a lot to learn about mappings. Let's take a pause right here and continue in the next video and start implementing this refactor. So quick break, and we will start that in a minute.